Large language models generate answers. Now AI agents can do work. But processing agentic AI is a whole different kind of problem. Agents observe, reason, plan, use tools. They manage massive context, juggling working memory and long-term memory. They spin up sub-agents, specialists on demand. NVIDIA Vera Rubin is a multi-rack pod-scale system built to process agentic AI and is now in full production. The manufacturing, automation, and orchestration across the supply chain, a miracle to witness. Our journey started when we launched the first AI supercomputer, NVIDIA DGX1. Over the next decade, we pushed every chip and system to the limit, from Pascal and the first NVLink to Grace Blackwell, the first rack-scale AI supercomputer. And now, Vera Rubin, the first multi-rack pod-scale supercomputer, built for the agentic age. It starts at TSMC. The 7 new chips that make up Vera Rubin take shape through hundreds of processing steps. 3-nanometer process, CoWoS-R and CoWoS-L packaging, HBM4 memory from Micron, SK Hynix, and Samsung. The Vera Rubin compute board, 6 trillion transistors with over 18,000 components on one board. Vera Rubin NVL72 does the thinking, prompt and context understanding, reasoning, and planning. Next, a new modular compute tray, streamlined with a new PCB mid-plane design, super chips, Connect X9 Super NICs, and BlueField 4 DPUs, all made in place, with no cables for resiliency at AI factory scale. 18 compute trays, 9 hot swappable NVLink switch trays, new high-efficiency manifolds, liquid-cooled bus bars, carrying over 5,000 amps, the equivalent of 20 electric cars at full acceleration. Together, 1.3 million components form this third-generation MGX rack design. Congratulations to Microsoft for their operational Vera Rubin NVL72 engineering rack. Congratulations to Dell and CoreWeave as well for standing up their Vera Rubin NVL72 engineering rack. Then, the Vera CPU rack, 256 CPUs in a single liquid-cooled rack, orchestrating the models, shuffling memory, launching tools. At Foxconn and Quanta, Grok 3 LPX takes shape. 256 Grok 3 LPUs across 16 trays, 40 petabytes per second of SRAM bandwidth for ultra-low latency. While NVL72 generates tokens at the highest throughput, Grok LPX generates them at the lowest latency. Vera BlueField 4 STX, where AI keeps its memory. Storage processing accelerated by BlueField 4, connecting memory, storage, and in-silicon security. And NVIDIA Spectrum X Ethernet Photonics, the world's first Ethernet switch with 200 gigabit co-packaged optics, TSMC's COUPE process, chip-scale packaging, and ultra-high-powered laser dyes on indium phosphide. Vera Rubin, 5 connected rack-scale systems, a supercomputer for AI agents, 150 supply chain partners across Taiwan, millions of square feet of factory floor, hundreds of sites, chips, packages, systems, and data centers pushed to the limits of size, power, and scale. This is what we call extreme co-design. We did this with Taiwan. Together, we reinvented computing for the age of AI. Taiwan was with us at the beginning, and here today as we bring Vera Rubin to the world. Thank you, Taiwan.